Hello again. We are getting close to the end of Unit 12. This is Section 8. We're expanding what we talked about in the last section. We started talking about sine and cosine and tangent graphs specifically. In this section, we're going to talk a little bit more about how to translate those. So we're going to talk about horizontal translations, which are also called phase shifts, and vertical translations of trigonometric graphs. So the new vocabulary you should be on the lookout for is phase shift, vertical shift, and midline. So we're going to start by talking about horizontal translations. Again, a horizontal translation of a trigonometric function is called a phase shift. Remember that translation is when I move a figure or a graph from one place to another without changing its orientation. So I'm not reflecting it or anything like that, I'm just moving it. And we call a horizontal translation of a trig function or any periodic function a phase shift. So phase shifts happen when I have something added or subtracted to my theta inside of my trigonometric function. So just like with other functions, if I have something added or subtracted inside my function, it's horizontal translation. Same thing with trig functions, with periodic functions. So if I take a look at this first graph here, y equals the sine of theta, the blue graph is the original one, right? And then the red dotted graph is showing you if it's moved h units to the right. So remember, if it's minus h inside my function, it moves to the right h units. And if it's minus h where h is negative, so this would normally look like plus h or minus a negative h, it would move to the left h units. So if I look at these examples down here, if I have the cosine of the quantity theta minus 90 degrees, my phase shift will be 90 degrees to the right. If it's the tangent of theta plus 30 degrees, it'll be 30 degrees to the left, just like we've done with other functions before. So let's take a look at this first example. We're going to find amplitude, period, and phase shift for this function. So amplitude and period come from the last section that we looked at. Our a value is 2, so my amplitude is 2. B is 1. B is this number here multiplied in front of the theta expression. So since B is 1, the period is going to be 360 degrees, just like it was before. But this positive 20 degrees that's inside, remember that means minus negative 20 degrees. That means I have a phase shift of negative 20 degrees, or 20 degrees to the left. So in order to graph this, we would want to think about the graph of 2 sine of theta. A lot of times we start with that, and then we graph that, and then we shift it 20 degrees to the left. So let me show you what that would look like. So again, our amplitude is 2, because my a value is 2. Period is 360 degrees, and my phase shift is 20 degrees to the left. So what they're showing you here, the dotted line would be like my parent function, in this case, with an amplitude of 2. So notice it comes up to positive 2 and goes down to negative 2. So if I just had 2 sine of theta, that's what it would look like. A lot of times it helps to graph that first. And then the blue one is my final graph. It's shifted to the left 20 degrees. So I just take every point. So for example, 180 degrees is now 160 degrees. It's shifted 20 degrees to the left. All right, so you guys check your progress with this one. Find the amplitude, period, and phase shift. All right, the answer here is C. Amplitude of 3, because that's my a value. My b value is 1, so my period doesn't change. It stays 360 degrees for the sine function. And a plus 30 inside with my theta means a phase shift of negative 30 degrees, or 30 degrees to the left. I hope that on the graph that I put on your note guide, you will try to graph that. Practice graphing first. You will graph, if it will let me write, y equals 3 sine of theta, graph that with a dotted line, and then shift everything 30 degrees to the left. Okay, now we're going to talk about vertical translations. These are very similar again to what we've done before. If I have this graph, y equals x squared plus 5, my parent function is x squared, and that plus 5 that's added on the outside just moves it up 5 units. Same idea with trig functions. Vertical shifts happen when I add or subtract a value outside of my function. So if I add a k value, it will go up k units, which they're showing you here in this graph. If I add a k value that's negative or subtract a k value, it will move down k units. So here the sine of theta plus 4. Notice the 4 is not inside the parentheses, it's outside. So that's 4 units up. -3 outside my trig function is 3 units down. So this is just a notation thing. This, where my x is added to the theta inside parentheses, and this are not the same. This one would be a phase shift. It would move x units to the left. This one is a vertical shift, x units up. Okay, so those parentheses are a huge deal. In this one, I'm adding theta to x and then taking the sign. In this one, I'm finding the sign of theta first and then adding x. So they're very different. Midline, remember that's one of the words you were supposed to be on the lookout for in this section. When I shift vertically my trig function, this line y equals k is my new midline. The midline is the horizontal axis that my graph is oscillating around. So here, if I have a sine or cosine function, it goes up to the amplitude above the midline and below, right? So if you look back at graphs we've done before, for example, if I'm looking at the blue graph here, which is the original cosine graph, the midline is the x-axis, right? It's going above the x-axis, below the x-axis. When I move it up k units, I get a new middle line that my graph is oscillating around or waving around. And usually drawing in the midline will help when you're graphing vertical translation. So let's look at this example. I have y equals 1/2, so that's my a value, times the cosine of theta. My b value is 1, plus 3, that's my k value. That's moving me up 3 units. So my amplitude is 1/2. My period is going to be 2 pi, or 360 degrees, 2 pi radians, because my b value is 1, so it doesn't change. And vertical shift of 3. So if I'm going to graph this, I'm going to start by drawing in my midline. So since I'm moving up 3 units, I'm going to draw in y equals 3, that horizontal midline. It will help me get my graph as accurate as possible. Excuse me. Since the amplitude is 1/2, a good strategy is to draw in dotted lines for my amplitude parallel to the midline. So this is 1/2 a unit above and 1/2 a unit below. So that's going to tell me, okay, my graph is just going to oscillate between those two lines around this middle line or the midline. Then I'm going to draw in my cosine curve, right? Because it's not shifted left or right. There's no phase shift. So my point that originally would have been 0, 1 is now 0, 3.5. My point that originally would have been pi over 2, 0 is now pi over 2, 3, and so on. So I've just shifted my curve up 3 units and compressed the amplitude to 1/2. Okay, so you guys try this one, please. The answer here is A. Your amplitude, your A value is 3. My B value is 1, so my period stays 2 pi radians. And that -2 is a vertical shift of -2. So my midline would be the horizontal line, y equals -2. Hopefully, again, you will try to graph that one. Okay, here is the summary of graphing trig functions. This is important. You have this on your notes. Amplitude, the number multiplied in front of the trig function, especially sine and cosine. B, the number multiplied by theta, but notice it's factored out of theta minus h, right? The factor in front of that is the period. Well, that's not the period. We take our original period, 360 degrees, divided by that to get our new period. Phase shift, if something is added or subtracted to the theta inside the parentheses. And vertical shift, if I have a constant added or subtracted outside of my function. So step 1, when I'm graphing, find the vertical shift and graph the midline. That's the easiest place to start. Step 2, find the amplitude if it exists. Remember, for tangent functions, we don't have an amplitude. I draw in dashed lines above and below my midline to help me get my maximum and minimum values, so I don't go beyond that. Then we're going to find the period and graph that function, right? And then usually we'll graph this with a dotted line, this part here. And then we'll figure out the phase shift, and we'll take what we graphed in step 3, shift it over left or right, and then draw in the actual graph in step 4. So let's take a look at what that process would entail. So here we have a beautiful function, 3 times the sine of the quantity 2 times the quantity theta minus pi over 2 plus 4. So we're going to find our values of A, B, and K first. A value is easy, just the number in front, which is 3, so my amplitude is 3. B equals 2. Remember, I take that B value, I take my period, which is 2 pi radians, because I'm dealing with the sine function. I divide it by 2. So my new period is pi, meaning my sine will do one whole revolution or one whole cycle in pi radians. H is pi over 2, so I'm going to move pi over 2 units to the right since it's minus pi over 2. And then K is 4, so my vertical shift is 4 units up in the positive direction. All right, so we're going to start by graphing our midline. So they're showing you that here. Notice again, my x-axis is the angles in radians. So I graph my midline, which is 4. We said our amplitude is 3. So I'm going to draw in a dashed line 3 units above and 3 units below. You should be doing this along with me on your notes. Pause if you need to make sure you have time to draw it in. So this tells me that my maximum value is going to be at 7 and my minimum value at 1. Period is pi. So I'm going to graph this function. Notice it's without the horizontal shift, without the phase shift, using my midline as a reference. So how did we get here? There's a few ways you can think about it, but what we're really doing is we're plugging in theta and we're getting y. So for example, if I plug in 0, the sine of 0 is 0, times 3 is 0, plus 4 is 4, right? Then normally my next main point would be at pi over 2. The sine of pi over 2 is 1, but when I plug pi over 2 in here, I end up with 3 times the sine of pi, because 2 times pi over 2, I can show you that if you want, would look like that. So I end up with the sine of pi, and the sine of pi. The sine of pi is 0, times 3 is 0, plus 4. So when I plug in pi over 2, I get 4 again. So we want to plug in something halfway between 0 and pi over 2. So what happens when I plug in pi over 4? 3 times the sine of 2 times pi over 4, plus 4. 2 times pi over 4 is pi over 2, so that 3 times that plus 4. The sine of pi over 2 is 1, times 3 is 3, plus 4 is 7, so that takes me up all the way to my maximum value. And then I keep going. When I plug in 3 pi over 2, actually I mean 3 pi over 4, because I want to plug in this point right here, 3 pi over 4. When I plug that in, I actually end up with negative 7. And then I head back up and I hit my midline again, and then I hit 7. Okay? So if you're not sure how to graph it, you can plug in points. Basically what's happening is we're taking our original sine function and we're compressing it into 180 degrees, so everything's getting cut in half horizontally. But that's not even the graph we want to do, right? I would graph what I was just showing you in dotted curves like this. And then I need to shift that pi over 2 to the right, because this is my original function. So I take every point that I found on that dotted line and I shift it pi over 2 units to the right. So this point comes over to here, this point comes over to here, this point comes over here, and so on. So that solid blue graph would be my final answer. All right, last one. You guys try this one. Okay, your answer here is C. Your amplitude comes from my A value here. My B value is 3, so my period is 2 pi, the original period of the cosine function, divided by 3. Phase shift is pi over 4, it's positive, so that's moving to the right, pi over 4 units. And my vertical shift is down 2 units, or a negative 2 vertical shift. Try graphing it. See if you can figure out what that would look like. That is the end for this section. There's a word problem that we'll probably talk about in class. But for now, just make sure that you understand where your A, B, H, and K values come from so that we can practice graphing in class. I'll see you then.